This is question 3 from chapter 5b. We're given the three equations here and we're asked to solve for x, y and z by Gaussian elimination. So first step, we need to express that in matrix form. So using the coefficients of x, y and z, we're going to fill out the matrix. So the first equation has no x, so the coefficient is 0. For y, the coefficient is 2 and z, the coefficient is -1, giving an answer of 5. For the second equation, the coefficient of x is 1, there's no y, so it's 0, and z is 1, answer -1. And for the third equation, the coefficient of x is 2, for y it's -1, and z it's -1, answer of 6. Okay, so the first thing I'm going to do, I'm going to swap row 1 and row 2. So simply switching their places now. And the bottom line isn't going to be changed. Next step, we're going to do row 3. Actually, sorry, I might just change that. So here we'll do row 3, take away 2 lots of row 2. So that will give me 2, take away 2 will give me 0 here. Then we'll have -1, take away 0, so we'll have -1. 2 lots of row 2 will be row 3, -1, take away 2 lots of 2 will give me -3. And we'll have 6, take away -2 will give us 8. Okay, for the next step, I'm going to look at eliminating the -1 in the bottom row. So I'm going to leave the top row as is, and the second row. And what I'm going to do is I'm going to do 2 lots of row 3, and I'm going to add on row 2. So that will simply give me 0 in the first position. Then we'll have 2 lots of -1 plus the +2 will give us 0 here. And then 2 times -3 is -6. Take away 1, we get -7. And for the next position, with 2 times 8, 16, plus 5 gives us 21. Okay, so now for the bottom row, I'm going to look at getting into the identity matrix form where I need a 1 in that position. So I'm going to do -1/7 multiplied by row 3, so that will give me 0, 0, 1. And 21 divided by -7 will give me -3. Now for the top row here, I'm going to do 7 lots of row 1 and add on R3. So that will give me 7 in the first position, a 0 in the second position because these two are already zeros, and then 7 times 1 is 7, add on the -7 we get 0 here, and then we'll have -7 plus 21 will give us 14. And now for my middle row, I'm looking to eliminate the -1 I have. So I'm going to do 7 times R2, and I'm going to take away R3. So first position will be 0. 2 times 7 is 14, take 0 is simply 14. And then we'll have -7, take away -7, so they cancel, we'll have a 0 here. Then we'll have 7 5s are 35, take away the 21, we'll be left with 14. Nearly there. Because I want to get the identity matrix on my left, I need to do 1/7 of row 1, so that will give me 1, 0, 0, and then 14 divided 7 will give me 2. On this second row, we need to do 1/14 of row 2, so that gives 0, 1, 0, and then 14 divided by 14 will simply be 1. And the bottom row is already okay, so just 0, 0, 1, -3. So now if I read off from my matrix, that then tells me that x is equal to 2 from reading the top row, y is equal to 1 from the middle row, and z is equal to -3 from the bottom row. And then we should do our check. So if I use my equation 2y minus z, 2y is 2 times 1, take away -3, we get 5. So that one's correct. If we do x plus z, we get 2 plus negative 3. That gives me negative 1, which is my correct answer. And my last one I've got is 2x minus y minus z. So 2x will give me 4. Take away 1, take away negative 3. 4 take 1 is 3. Plus 3 gives us 6, which is the correct answer. So that verifies that x, y and z are those values.